So, welcome. I'm David Bowman. I'm the Executive Director for the Four Corners Regional Education Cooperative Number One up here in Farmington. And today's session, we're going to look at a very cool application called Scratch. And just in a very brief nutshell, what it is a visual way to learn coding without having to actually learn coding languages, which is great. I had the great opportunity summer before last, when everything was shut down, school year before last, everything was shut down with the pandemic, that we ran some coding clubs for middle school and spent a lot of time with the teachers teaching them how to use Scratch themselves. And then they were running after school clubs, and it was great. So let me just jump over to that. I will mention that not only is it a great way for kids to learn coding, it's also a lot of fun. So let's get to it. Let me share my browser. All right, so there we are. Let's see. I think you ought to be able to see this now. Okay. So in a nutshell, what Scratch is, it's a visual way to assemble code without having to learn any coding languages. And the nice thing is kids can then focus on the logic and the structure and the concepts behind coding that they can use for any programming language. Whether it's something as simple as VBA, which I seem to do a lot of, or C++ and so forth, there are certain concepts and principles. How do things fit together to make something happen? And that is what Scratch is exceptional for. So let me just take a quick browse on this, and then we're going to jump over to another site called Google CS First that teaches kids coding through Scratch. And it's a really great way to help kids learn the fundamentals of using Scratch. But let's take a look. So this is just the home page here, and featured projects, things that kids have made. There are quite a few adults that do Scratch programming because it's fun and interesting, but it's really targeted at lower elementary through middle school kids. Although, frankly, in my personal opinion, for high school kids that have never done any kind of coding but are sort of interested in that, this would also work very well for them. So let's see how it works. Let me just pop over to one of the projects. That's my account. We'll skip that. So here's what a sample Scratch application looks like. And I guess I ought to mention that this is all 100% free. Free accounts, free coding, free everything, 100% free. So there aren't any kind of like you have to sign up and pay a fee or anything like that. You just go and do it. So this is a little game called Feed the Monkey. And as you'll see with Scratch, we can make games. We can use it for storytelling, which has some neat implications for instructional purposes. We can use it to make music videos or pretty much anything you or students can imagine. But this is just a little game here. I don't know if you'll be able to hear it or not. But here we've got a monkey going around eating bananas, and there's a counter. And if he gets too hungry, he actually dies. So we have to catch bananas. So this is an example of just one Scratch program. Now, let me show you something that's really neat about Scratch. And let me stop this. Let me hit the stop button up here. Okay. One thing that's really neat about Scratch is the coding that are used to make Scratch applications are all open source. You can always click on this big button on the top right that says see inside and see how the programs were built. All the pieces, all the if-then statements, when this happens, do that happens, move by this much and so on. But take a look at what we've got here. This is all 100% visually driven, which is why it makes a really good application for learning coding without having to learn the skills. So for example, let's take a look at a piece of this. When the start button is clicked, and you see that on the top, what are we going to do? Well, if the hunger is 5, play the chi-chi sound and wait a second and do it again. If it gets to 9, say, I'm hungry, and so on. So if this happens, it triggers something else to occur, which is a fundamental aspect of all coding. It's like an if-then statement. Um, here's the bananas. Okay, if we click a banana, stop the other scripts, make it fade away, and change the score. So we assemble the actions and we assemble the commands visually to make happen what we want to have happen. And as you'll see, as I tear this apart a little bit, all we are simply doing is assembling blocks of code. And we can find all of those blocks over here on the left-hand side. So for example, motion blocks, turn to the right a certain number of degrees, turn to the left, go to a random, and glide and so forth. We have event actions. When the space bar is pressed, what do we want to have happen? When the loudness reaches a certain level, what do we want to have happen? We've got controls, which is our if-then statements, wait statements, stop, start statements. We have sensing commands when this touches that, for example. Operators greater than or less than, but you see, the neat thing is they're visual. So all that the students have to do is be able to assemble them in a way that will make happen what they want to have happen. And then you see all the white circles, put in whatever variables that they want. When this equals 50, and we change it to 20, change it to 15, and so on. So we can take the commands and then modify them according to how we want them to look. So let me show you a story example. But that's basically what Scratch is. Create an account or not, assemble the blocks together in a way that meets the logic, which means that the majority of what we're doing here is not coding per se, it's thinking. And when I've done a lot of classes on coding, and this forum and other languages also. I've got one coming up on Excel VBA, for example, that'll be in March. But a lot of the really heavy lifting is not putting the code together and assembling the pieces. It's the thinking process. What do we want to have happen? How should those events be triggered? What do we want the user's experience to be? So it's that part of it, which is purely conceptual, that Scratch is amazing at teaching kids how to do. So let me pop over to another one. This one, and I'll let this one play. This was made by, I don't know, a kid. Make me your radio. So this is a story.
I did better when my car had sound. If somebody stole my car radio and now it's just sitting silent.
And it goes on from there. So it's a little animation, a little music video that kids have put together in order to tell this story. Let's see how it works. Let's see some interesting pieces. So there's the code again, right? And there are basically two things that build every Scratch application. You have the code, like what's going to happen when this happens, do that. Go here, go there, and so on. And the other thing you have is something called sprites. And sprites are the things that actually show up on the screen. So down here on the bottom left, we have sprites, okay, which are the visual elements. And the code will cause the visual elements to do something. So what do we have? So up here, if you look on the upper left, we've got code. And there's all of our code blocks there, which I've kind of talked through. Here's how this person has assembled them. But then we also have something called costumes. In costumes, if you think about an animation, for example, Animations are built by a series of individual still images that merge together or that play one after the other and they cause something to happen. And that's kind of what costumes are. So we see that this person built a lot of costumes, and each one's going to be a little bit different, but they are triggered by the code. So here's one costume. Here's the next costume for that sprite, the next one. And you see they're each a little bit different. So what we'll find in the code then is something that says maybe a loop, repeat 10 times, go to the next, go to the next, go to the next, go to the next, go to the next. And it will cause, as we cycle through the costumes, it'll give us a nice animation effect. The third element of any Scratch applications, we got code and we assemble it. We've got costumes. So each sprite has one or more costumes. And the third thing we have is sounds. Let me find a sound. Now, there is a huge library of sprites. It's kind of neat that kids can make their own sprites. They can draw them right in the visual editors and the drawing tools of Scratch, but they can also just go to the library and find them. And the same thing with sounds. They can load in their own sounds. They can do voiceovers if they wanted to do that, or they could use the Scratch library of sounds. So let's see what this one looks like.
I liked it better when my car had sound.
So that's the background. Let's take a look at costumes and sprites. So let me just say choose a sprite. So you'll see that Scratch comes preloaded with a lot of different sprites. And let's say we want a dinosaur. Okay, so we've added the dinosaur. And that dinosaur comes already with a variety of costumes. Now we can add to them, we can modify them. You see we've got drawing tools there, but it comes preloaded with a handful of sort of best guess useful costumes already. And as you see, I have put that sprite right into this person's presentation. Now, the fun thing is you can go and monkey with other people's Scratch applications. You can't save them. All right. What you can do is you can make your own copy in your account and then modify and save your changes that way. So you can actually go and get somebody else's project, bring it into your own account, and then modify it or use pieces of the code that they use. We'll talk a little bit more about instruction and some of the things we found out with that after school coding club. But the point is this: the user has an enormous amount of flexibility when assembling Scratch applications. The tricky thing, of course, after figuring out what you want to happen, the tricky thing is now how do we actually make the events occur? How do we go from an idea to code? How do we get the sprites in to do what they want to do? How do we get the sounds in the right place? How do we get them to do things, basically? But those are the basic elements. So we've got sprites, we've got code, we've got costumes, we have sounds. We can go and look at other people's projects. We can actually put them into our own accounts. We can look at their code and use snippets of their code. So if we see something like, wow, how did they do that? We can learn from other people's applications and then use them in our own without ever once having to learn a coding language. Let me see if I can get rid of that sprite that I installed there. Okay, there we go. It's gone now. So let's take a look at one more. Let me show you one little one that I did, and then we're going to jump over to Google CS first, which is a really super curriculum. I don't see many things that really impress me, but Google's CS first blew me away, frankly. So I really want to show that in just a moment. But let me take a look at just a little thing that I made for my wife's kindergarten class. when she was teaching kindergarten last year in Santa Rosa, she's teaching the kids about shapes, and not just the types of shapes, but also whether they're flat or solids. You know, a nice little kindergarten thing. So I built this for her.
Square.
So it pulls up a random shape, it reads it, and then I can say, what
Circle.
shape is it? Oh, that was wrong. Let me try sphere.
Sphere.
No, that's wrong. I don't know if you can hear it, but can you hear it saying the words also? Yeah. And then we get the right one, square.
Square.
Bing dong. What type is it? Solid?
Solid.
No.
Flat.
Flat. And then it'll randomly cycle through and come up with another one that we can then
Sphere. Solid.
that we can choose. And then it cycles around again.
Rectangle.
The coding on this actually wasn't very difficult. It looks kind of wild because there's a lot of little pieces, but basically there's only a few things happening. We've got to come up with a shape, and there's a process to cycle around a random number of times. It's just going through costumes a random number of times, and it lands on a particular costume. It reads what the costume is and says the name of it. Then when we click on something, if the thing we click on matches the shape, I have a little code in there that says, all right, move my guy, my little cat, over to that shape, play a sound, and put a check mark. And it's got a counter. So a nice little application for kindergarten that I built over one weekend. All right, so tons of fun. Let's do one more very, very quickly. This is one of our students in the after school coding club had started to work on. He wanted a little drop down catch 'em game, and he got stuck. So we spent maybe half an hour together finding out, well, where is it breaking, basically? Where is it not working? Because one thing we learned with coding is it will only do what you tell it to do. And if you tell it something impossible, then it's going to break, right? So he had gotten to a point where it broke, which is kind of a nice little learning moment. Okay, let's read through it. What's happening? What do you want to have happen? And then looking at the code to see, well, where are we going awry? So we worked on that for a bit, and then I went off and made my own version. So let's just grab medium over here. Oops, missed one. Okay. I think you get the point. I'm a little bit leery about playing things with loud music because I do have a sleeping child in the other room, but I think you get the point. But it was something that the student had basically made, and I just added a couple little features to it at the end just for giggles. So how did we learn to do this? Well, there's a couple things. Obviously, just start playing and trying, but that's probably not going to work for most kids or most adults. We can go look at other people's programs and look at their code and see how they did it. But there's something really amazing I want to show, and it is called CS First from Google. And if you just do a Google search for Google CS First, it will take you to this page right here. And what this is a free curriculum online designed to help kids learn coding using Scratch. Anybody can do it, no experience, curriculum, and so forth. One nice thing about this, again, all free. One nice thing about this is, as a teacher, you can set up a teacher's account. You can set up a classroom and invite students to that classroom, which will give you the chance to assign lessons to them, a chance to see how far they got in their lessons, to actually take a look at the programs that they're developing, how many lessons have they done, and so forth, and where you might want to intervene. So it's pretty cool that way. You don't have to do it, but the teacher login does give some pretty neat opportunities, which we'll take a look at here. So let's see, what do we have here? So let's set up account, explore the home page. All right, let me actually log in as a teacher. And I'll show you some of those pieces. Then I'll show you some of the lessons because they're really well done. Like I said, I see a ton of stuff. A small percentage of it impresses me. This was super impressive to me. I guess you can see that because that's my email address. Okay. And I'm just logging in with my Google account. There we go. So you see, now that I've logged in, this is my dashboard here, and I've got 4 classes set up. The CS for MS sponsored class, which I built for the teachers who were running their various clubs, after school clubs, one for the kids themselves, and then just one throwaway sample, Bob's Fun Code for coding. So from here, then I can pull up my class information, and it's going to tell me some neat things. First thing it's going to show me is what lessons or what units have I assigned to the students in that class. And I've got 1, 2, 3 that I've assigned to them. I can look at what activities did they view. I can look at projects they have submitted and where they are in each of them. There's a survey that I can do. All right, let me go back to my class. So just some ways to sort of check and see where kids are in the process. And I'll tell you one thing they did that I think is super smart, and I really wish it was more often, more common. In the students section, I can add kids, obviously. But one thing it's going to let me do is pull up their usernames, and there's a report I can generate of their passwords also, because one thing that I know about kids and most adults is somebody's going to lose a password somewhere. So as the teacher of the class, I have access to it, and I can just tell them what their password is. I can add co-teachers to also help teach the class. All I have to do is share the class code, and that will allow students and others to join me. Well, let's take a look at the curriculum. How does it work? Because this is where it gets really interesting. So each one of these that you're seeing here are sample units or sample projects. Let's just take a look at one of them. And I know which one I want if I can find it easily. Unusual discovery. Video-based, introduction, 1 primary lesson, takes 1 to 2 hours, and it's available in Spanish. I can add it to my class and assign it to one of my classes. But let's actually just take a look at this. If I were introducing this to students, or to teachers or whomever, this is how I would do it. I would go to Google CS first. They have to set up an account, right? Help them set up a student account. And then I would use the units and the lessons here to teach them how do you do Scratch coding. So what have we got? So this is one of the units, an unusual discovery, and just a little blurb about it and so on. Lessons, examples of completed projects that I might show with my students, like, hey, here's some different things we could do with this lesson. And materials, where I can download cheat sheets or tip sheets. I can download my lesson plan and so on if you have to submit a lesson plan and so forth. But let's get inside and look. So each one of these lessons has a set of video instructions that come with it, where there's somebody who's going to walk us through step by step by step on how to complete this. And I'm going to skip ahead.
Games, share memories, story, and add it to your project.
So she's going to walk me through all of the steps for completing this activity. So once I've seen that, or I keep that open in a different tab, what I'm going to do is I'm going to come over here to links, and there are starter projects ready to go. And then I can use what she's teaching me step by step to go and replicate it or echo it, mirror it on my own project. So let's choose Jungle Adventure, and it's going to open up in a new tab. Welcome. Okay, got it. And here I've got my blank background already built in, and I am ready to start going through the instructions on the lesson plan, but also I find the videos more useful where I can say, all right, what do I do now and how do I do it? And the video is going to walk me through the entire process of creating my own project and show me where I can modify it, what kind of changes I can make to it. But it's going to teach me all of those skills that I need for coming up with, determining what code I need and how I can assemble the code together to create my own project on this unit. Now, so that's cool. So that's the basic lesson. But then, and I think this was a really neat idea. I don't know who came up with this, honestly, but well done. So I can create my basic project, but then there are additional things that I can do to make my project even more robust and more interesting. And each one of these is something that I can do. So let's say I want to make my objects bounce up and down. Okay. I'm going to get a video on how do I take something from the project I just made, and in this case, make it bounce up and down. And there's our friend, and she's going to walk me through it. So I can then on my project come over here and replicate it as well. So what's the point of all this? The point of all of this is not just learning how to code, but learning how to do the logic behind code and the critical thinking behind assembling code. Is one of those sort of lifelong valuable skills that are going to serve all kids well. And coding part is fun and learning to make games, and surprisingly, a lot of kids are interested in that. But it's those critical thinking skills behind it that are the true value of learning to do this. And this is a good vehicle for doing it. And this is just her video over here. She's showing us the pieces. So then she's going to wrap it up towards the end. Now it's your turn. And here are the steps that I need in order to complete that project. So as a teacher, then, I'm going to start a class. I'm going to create a new class. I'm going to assign kids to it. They have to have their own account. And I'll send them my code for the class. So this code is WCR6PT. Okay, and I can just copy it. There, it's copied. So I can send it to them. I can assign lessons to them, and then I can monitor and see how well they're getting through those particular lessons. And then step by step, using the units and the activities and the videos and so forth, the kids can walk through them, or I can walk through them with them, and we can actually learn to do the coding on Scratch, which is very, very cool. So a couple of things. So some lessons learned from these coding clubs that we had. A few things we found to be really most useful. First is have the kids work in pairs. Not only because kid A remembers something that kid B has forgotten, but more importantly, there's sort of a sharing of ideas where one person's idea spurs a more advanced idea from the next person, and together they can come up with some really interesting things. The second lesson we learned that turned out to be really useful is to let the kids go and explore. Over here on Scratch, there's an explore button. Let them go and find something that's interesting. Find a project that's interesting. Identify within that project one sort of topic, like this is a really interesting program to me, and here's the thing I liked best about it. Have them go into the code, find out how the person did it, and then share that with others. So for example, they might say, hey, this scrolling platformer was a really fun game to play. The thing that I liked most about it was blank, and here's how it's done. So it gives that sort of exploratory learning. I mean, one thing we know for sure about learning is that people learn things best when they're interested in them. So we give them the chance to go out and find something interesting and learn how it's done, something that maybe they want to put into their own programs. And certainly encouraging kids to make copies of the other people's projects. I mean, normally we'd say, wow, plagiarism, this and that. They were not copying stuff. Okay, it's fine. But in the real world, we're doing that all the time. And certainly with coding, we do it all the time. Here's something I want to learn. I'm going to take that person's code, I'm going to copy it, and then I'm going to modify it for my own purposes. And during that process, I'm learning something. So I actually strongly encourage kids and others to do that. Find something interesting, copy it without shame, but then turn it into something that is uniquely yours, right? And you will learn from that process. The other thing that a few more things that we found useful as kids were working on their projects, and the teachers also, um, have regular periods to report out. Here's what I'm doing. Here's what I'm trying to accomplish. Here's what I want this game or this video or this storyboard to be about. And here's where I'm in the process, and here's where I'm stuck. And give them a chance, to be a little humble and say, all right, here's where I'm stuck. How can I fix it? And let the other students chime in on that, because then they're all going to learn from that. One thing that I think is true for a lot of people is people don't want to look like they don't know something, whether they are 8 years old or 80 years old. To say, I don't know. And a lot of times when we have teachers in front of students, I mean, there's a mix, obviously, but many teachers are kind of hesitant to be the one who doesn't know anything. But that's okay, right? I think when teachers are like, hey, I'm learning this also, and I don't know, let's go figure it out. Or have the kids run off in their groups, find the solutions, and then teach it to me, the teacher, and to the other students. That puts the students in a very interesting position, in a very empowering position, that's going to do two things. One, it gives them a chance to learn some new stuff. And B, it gives them a sense of self-efficacy, like I am not just a recipient of information, but I'm a person who's actually learning and sharing. And the final thing that we did that seemed to work out very well, at the end of the coding clubs, kids worked on capstone projects. They're learning new stuff, but kind of early in the process, we had them come up with an idea for a game or a story or a music video or whatever they wanted. And then as we were learning all the skills around Scratch, to start applying those to their idea, so that throughout the course of this, they're learning more stuff. They're continuing, spending some time fleshing out their own projects. And at the end, we did a kind of a very nice event where students got to show off their projects, and we had some awards. We had every kind of award from most engaging game to the weirdest background, and everything in between, like who used the most sprites and whose code was the shortest. Just we came up with a lot of different types of categories, and that wasn't really the point. The point was to give students the chance to come up with their own ideas, learn the skills, and then have a chance to celebrate it, to present and celebrate. And so that's how we did it. And it turned out pretty well, actually, all in all. So a couple of things I would recommend. One, make a Scratch account. Join Scratch. It's free. Go and play. You don't have to make an account. You can go and play all day long if you want to. You just can't save your own stuff. But then if you're thinking about actually using this with kids, I would really recommend going over to CS first, setting up an account, building some classes, assigning with kids, assigning lessons and units to them, and then working on them together. Even for teachers that don't know coding, and of our sponsors that we had for those clubs, there were a few who had done some coding, but most of them had never touched coding. It just looked kind of neat. They had never, ever done it. So we all kind of learned at the same time. because why not? So that's kind of everything around sort of the overview of Scratch, what it does, how it works, what it looks like, and some resources for learning through CS first. And that's pretty much what I got. So let me pull out one last little thing as soon as I can find it. So just as an FYI, here's one that I'm working on for some instructional purposes. I'm doing this for my wife's class again. A quiz game, right? Can we actually make a quiz game? Click on the door. And there goes our guy. And he talks to us. Okay, click me to begin. Water is a solid, liquid, or gas. Water is a liquid. Hoorah! I now have a point. How many planets? 8, 9, or 11? I'm going to choose the wrong one here on purpose. I'll choose 9 because there's only 8. And which one of these is a mammal? Cow. All right. And it goes on from that. It's a little quiz game that I'm making for her kids. And it's actually not too difficult, the coding behind it. But I can go in and I can monkey with it all day. Or I can find somebody else's game, quiz game, see how they did and say, is that something I can use in my own project? So that's the overview of Scratch, of CS first, the way it works, and some things that we can do with it to help kids and the adults learn some very important, lifelong necessary skills. Any questions from anybody? This was sort of a race through. I mean, today was not about learning to code. It was about learning to, some of the resources we have for learning to code. If we want to actually learn Scratch, we need a much longer session. When I did it with the teachers, we spent 3 very full days, 3 very full Saturdays learning the fundamentals of Scratch ourselves. And they got pretty good in that amount of time. So questions, ideas?
This is much different than Code Spark, but have you used them interchangeably?
Code Spark, I have not used Code Spark.
Okay.
Yeah.
That's what I used in my kindergarten class, and they had to do basic coding to get the little character to, jump over something or knock into something or climb over a wall. But I like this because it's a little bit more creative, like they're making up what they want them to do. And then that CS1, would that work with Scratch Junior?
CS1, like the Google CS first?
Yeah, that CS first. Yeah.
Sure.
So there was some kind of interface between Scratch and that. Would that work for the junior version? Because that one seemed a little bit easier for younger kids.
It should. I don't know if CS first has actually the skills and the lessons that CS first have don't get to a very advanced level. So I'm gonna assume probably yes, because it doesn't get all that advanced really. There's some really crazy things you can do with gravity generators and scrolling platforms and so forth, but that's sort of above and beyond the basic knowledge of Scratch that's available here. I will mention one thing. If folks are interested, I'll throw this out there as an offer. If there's some folks that really want to dig into how do you use Scratch, and I want to spend a day or a couple of days and I want to actually learn how to do this, not just about it, but actually get in there and learn how to build code and so forth. I'd be happy to think about putting together a session or some sessions on that. It does take a bit more of a time commitment, obviously, but I'd be happy to do that. It was a lot of fun working with the teachers on building code and I knew some. I was half decent. I could do all the sort of the basic stuff. I was half decent. Like I said, most of them didn't know anything. But by the end, we were all doing some pretty neat things. My skills went up, their skills went up, and we had a good time doing it. So just throwing it out there. If any folks are interested in actually, like, I want to learn Scratch and I want to do a workshop on it, I'd be happy to set something up. Just let me know. Anything else? Kendra, it looks like you're about to jump. You're probably in your, yeah, all righty. In your letters training, not a problem. Rose, Jennifer, others, any questions, anything I can answer for you about this? Okay, I'll go ahead. Hi, Rose. Can I change this so I'm the primary speaker gallery? Okay. Well, I will say thank you to all of you who showed up today. Just as an FYI, if you'll take a look at our website on the Tech Bits page, it's just nmrec1.org/tech-bits. This session will be being recorded, will be on there, and the sessions that I have done most recently around using Excel to analyze student data, they are also on there. So feel free to jump over. You can just, it's on our webpage. You can find it on there. So if you want to go back and look at the archive sessions, you're welcome to do that. But otherwise, I will say thank you all very much. And I hope you have a lovely day. Again, I'm David Bowman, Four Corners Regional Education Cooperative #1. Have a great day.